Amar Sahu from Weltec University. I am doing my final year project in Ennore Thermal Power Station. My teammates are Yuvraj Mahato, Viswajit Singh Dio, and we are doing a project on experimental investigation on boiler tube failure. Our guides are Mr. K. Logesh, Assistant Professor of Weltec University, and external guide is Mr. S. J. Padmanabham, Junior Engineer in Ennore Thermal Power Station. Abstract. As we know that the boilers have a finite line because of prolonged exposure to high temperature and pressure, but there are certain conditions in which the finite life has been reduced. So our aim is to find out the ways and measures due to which these life are reducing. Some common causes are wear, corrosion, latent heat, and structural growth. The goal of this failure investigation is to understand the root cause and give certain remedial measures. Our objective is to reduce the number of failure and thereby reducing the number of the breakdowns. This will also increase the boiler tube life, thus the reduction in the maintenance and lightening of expenditure will be happen. Coming to the technical data of the boiler, the rated output will be 260 ton per hour and steam coming out of the boiler is of 540 degrees Celsius. Feed water rated temperature is 230 degrees Celsius. Coal calorific value is 43,000 kilocalorie per kg. The coal is basically of bituminous type and it has been ordered from Odisha. The maximum amount of water present will be 10% and maximum ash content in the coil will be 30%. This chart is showing annual shutdown analysis for the year 2010 and 11. As we can see that the number of days for shutdown is highest in boiler puncture. Thus we can say that the motto of our project of doing because of boiler puncture is the toughest challenge faced by the ETPS. Certain techniques we are using in this project are on-site examination, visual inspection, micro-examination, chemical analysis and mechanical test. Coming on to the first examination, the on-site examination, it includes photographing of the fracture pad and collecting the sample of the study at laboratory. This sample and photographing is taken before the fracture, during the fracture and after the fractures. Certain conditions of this photographing are working parameters like temperature, pressure, which is useful for determining the failure reason. In some tie-up situations at the ending of the stage, this can lead towards the solution of the problem. These are the sample of the boiler tubes in working condition and the failure. The cutted portion has been given for chemical analysis. Some of the data collected in this examinations are steam pressure 110 kg per centimeter square. The temperature of the tube is 366 degrees Celsius. The steam temperature coming out of the boiler tube is 540 degrees Celsius and power generated is 60 megawatt in which we are working. Coming to our next is visual inspection. Visual inspection deals with the nature of the fracture, whether it is brittle or ductile. In brittle fracture, we will be seeing some chevron and coarse-like structure on the surface that tends to point towards the fracture of origin. In fatigue, clamshell type of marking on the fracture surface determines its presence. Some of the causes of these fractures are long-term overheating as a result of gradual accumulation of deposits or scale on the surface. A visual examination will serve wall thickness and erosion. Coming to our next examination, that is the microstructure examination. Here we do a small cross section of the failed area was taken from the failed zone and the tube end is mounted on the conductive vessels. Mounted specimens were abraded, polished, etched, dried and their metallographic studies were carried out under the metallographic microscopes. Here we can see the thickness of the oxide layer is not uniform and the corrosion is intergranular in nature. When the seam is directly facing the flame, refinement of the grains along the vertical axis can be seen with a well-defined decarburized layer. This tube appears to be mostly affected by the flame impingement. We can see here the microstructure examinations in 100x, 200x and 500x. Our exam examination is conducted as per the ASTM A370-12A and it is based on IS 15086 and 2000. We notice decarbonations up to 0.05 to 1 mm and platelets of iron carbide in the pearlite structure of carbon steel will thermally decompose to spheroidized iron carbide. Further decomposition will lead to total degradation of graphite plus ferrite. The microstructure shows ferrite pearlite structures and spheroidized. There will be some laminar will be structures. Coming to chemical analysis of the failed component, it is carried out as certain where the material confined to the required specification for service in particular environment of temperature and pressure. The spectrographic analysis and atomic observation technique are used to determine the traces of alloying elements and harmful constituents. Electron probe microanalysis is a sophisticated technique used for detecting the presence of objectionable impurities and homogeneous sample doses. To Coming to the chemical analysis, we found the carbon is lesser than the original value. Manganese followed by manganese is also lesser than the original value. The original value of the manganese should be 0.90 and it is present 0.724. Silicon is increased gradually or marginally over the original tube. Sulfur is marginally over the original, that is 0.02 and it is present 0.025. This marginal increase in sulfur plays a very drastic role in overall failure. Phosphorus is gradually less, followed by chromium is also less, and nickel is also less, and molybdenum is also a marginal less than the original tube. The chart is showing that the red bar is the original value which it should have, but the blue one is showing the failed tube that it is having. Here we can see that in nowhere this blue and red is matching. Thus, it can be stated that the value of failed tube is very below or higher than the original tube. The report of this chemical analysis shows that there is a significant drop in the percentage of manganese and chromium, and sulfur increase marginally in chemical composition. The increase in the sulfur is marginally, but it affects very greatly. Mechanical analysis. The nature of the problem and the type of the failed component determines the mechanical test like yield strength, tensile strength, percentage elongation, impact strength, hardness measurement, blend test, flattening test, expansion, etc. The result of such tests shows if the metal is confined the required specification, tensile test and elevated temperatures are necessary to determine its failure. Mechanical test. Certain values after mechanical test are we got tensile strength as 513.07 Newton per mm square, yield strength we got 369.65 Newton per mm square, elongation on 50 mm tube is 22.20%, hardness in HRV is 77 to 70. So our calculation of hardness is done by Vickers, and we can see that there's two graphs. The bigger one is the standard value, that is it should be 275, but we got the values as 144, 148, 146, 147 and 149. We can state from this graph that the observed value is far lesser than the actual it should be. So we can state that this is one of the causes of boiler failure. Coming to the possible reasons of tube failure are overheating, erosion, corrosion, internal and external, ductile and brittle failures, fatigue and lack of quality control. So the first reason is overheating. The heat energy is shared by various heat exchanger in the boiler so that no part of is overheated, but we can say that overheating is unavoidable in certain conditions. Some of the causes in which overheating is done are same point heat concentration, silica deposits, flame impingement, non-uniform gas flow and poor quality of coal present. Erosion. Erosion in a boiler tube is basically because of the small solid or liquid particle against the surface. As the collapse of the gas-filled bubbles in a cavitation liquid occurs, the erosion produces. Basically, we have three types of mechanisms: abrasive erosion, liquid impingement erosion, and cavitation erosion. Corrosion is chemically induced damage to a material that results in deterioration of its material and its properties. There